Well, what we observed in the last 10 years in the atmosphere or so is that the atmospheric concentrations, the atmospheric temperature did not increase but stayed about constant with large interannual fluctuations.
Well, we know that climate change and global warming is not a process where each year is warmer than the preceding year and it's just this relentless march. The increase of CO2 is a relentless march. That is increasing at a very kind of predictable rate. But there's always more than one thing going on in the climate system. So on any given year we may have an El Nino, which is a big warming of the tropical Pacific, a big La Nina, which is a cooling of the tropical Pacific. These are probably the most famous naturally occurring forms of variability that affect year-to-year climate. On the decadal time scale, on any given decade, you have the same kind of thing. You can have a relatively cool decade, you can have a relatively warm decade. So all of these fluctuations are kind of going on, and in the meantime, in the background, you have the system that's trying to warm up due to the increase of greenhouse gases in the atmosphere.
Now, going into the IPCC this time, I would have said that, well, the trend over a 15-year record is not really very meaningful because of the natural interannual variability of the climate system. But as the IPCC evolved, it became more and more of a public issue, so we felt we had to say something about it, even though from an observational perspective, it's not a very reliable measure of long-term warming.
No, and the thing about so-called hiatus periods is we know they've occurred in the past in observations. Models simulate them very well, which is great because then we can study the processes in the models that produce hiatus periods in the models. And the flip side of hiatus periods are accelerated warming periods. We get decades of very rapid warming. The most famous one was the so-called mid-70s climate shift. So from the mid-70s to the mid-80s, global temperatures jumped up about 0.4 of a degree centigrade. That's almost half of the warming that occurred through the whole 20th century. Processes that produce the accelerated warming are just as interesting as these processes that produce these hiatus periods. It's all part of how heat is redistributed in the system. So during hiatus periods, you get more heat going down in the deeper ocean. During accelerated warming periods, more heat stays in the upper ocean. So it's really how the ocean responds to when you're trying to put extra heat in the system, where does it go?
The uncertainty is still so large that we cannot give a firm answer. So we had to state it that it's as likely as not that the energy up, that the ocean didn't take energy up or took more up. That if we go to the deep ocean, we only have measurements which can be used to make a reliable estimate starting in 1992. And from 1992 to 2005, the temperature of the deep ocean increased.
And we've tried to give some indication of what the likely explanations are, whether it might have something to do with forcing. Most likely it's mostly natural variability. And we can't really predict, I think, how it's going to go in the future, but I think most people would expect that the warming would begin again fairly shortly, but we can't really predict that. Like in 2007, the stock market dropped a tremendous amount. Would you predict it to keep going down or bounce back up? We'd sort of think, well, it's going to bounce back up, but we can't really say when.